The International Space Station Archaeological Project is a groundbreaking initiative that applies archaeological methods to study the International Space Station, or ISS. Led by Justin Walsh of Chapman University, California, and his colleagues, this project seeks to understand how astronauts adapt to the unique environment of space. Over the past 2 decades, more than 270 individuals from 23 countries have visited the ISS, creating a micro-society in isolation, confinement, and microgravity. Traditional interviews with crew members provide some insights, but they often miss the nuanced ways in which astronauts interact with their environment. This project aims to fill that gap. To explore the ISS environment, the team adapted a traditional archaeological strategy known as the shovel test pit. Typically, this involves digging small pits at intervals across a site to assess artifact distribution. However, in the context of the ISS, digging is not feasible. Instead, the team asked the crew to document 6 locations around the station by taking daily photos for 60 days in 2022. This innovative approach allowed researchers to observe how astronauts use different areas of the station, revealing discrepancies between intended and actual uses of these spaces. The first 2 areas documented were designated for equipment maintenance and located near the latrine and exercise equipment. Using a novel open-source image analysis platform, the team analyzed thousands of photos, identifying 5,438 instances of artifacts being used for various purposes. These artifacts included writing tools, post-it notes, and an augmented reality headset. By cross-referencing these images with astronaut activity reports, the researchers discovered that the area near the exercise equipment and latrine, though not designated for any specific purpose, was used for storing toiletries, resealable bags, and a rarely used computer. The analysis revealed that the equipment maintenance area was primarily used for storage, with little maintenance actually taking place there. This divergence from the intended use highlights how astronauts adapt their environment to meet their needs. The findings demonstrate the potential of traditional archaeological techniques to study remote or extreme habitats like the ISS. By understanding how astronauts repurpose spaces, researchers can gain insights into the dynamics of living in space, which is crucial for planning future missions and designing space habitats that better accommodate human behavior. The implications of this research extend beyond the ISS. As the first archaeological study conducted off Earth, it provides valuable lessons for architects and planners of future space stations. By understanding how astronauts use space differently than intended, designers can create more efficient and adaptable environments. This knowledge is particularly important as humanity looks toward long-term missions to the Moon, Mars, and beyond. The ability to anticipate and accommodate the needs of space travelers will be essential for the success of these missions and the well-being of their crews. In conclusion, the International Space Station Archaeological Project offers a novel perspective on life in space. By applying traditional archaeological methods to a new context, researchers have uncovered how astronauts use the ISS in ways that diverge from original designs and mission plans. This work not only enhances our understanding of the ISS microsociety, but also informs the development of future space habitats. As the project continues, further analysis of the remaining sample areas will provide even deeper insights. Ultimately, this research underscores the importance of adapting our approaches to study and support human life in the final frontier.